we are going to start with the coordinate system, and mainly there are three type of coordinate system we will discuss. The Cartesian coordinate, we are all aware of it, and the second is polar coordinates, and the spherical coordinate, yeah, polar coordinate, and third is the cylindrical coordinates. Okay, and let me start with the Cartesian coordinate only, so that you can feel it, the importance of it. And Cartesian coordinates, Cartesian coordinates. In the Cartesian coordinates, we take x, y, z. Yes, and okay, and let me take x, y, z. Okay, if I ask you, can I take any random, can I take y here and x here? Is it correct? And for this, the answer is not. You can't randomly choose any position, because there should be follow this rule. And z cap, the z vector, should be the cross product of the two vectors. I think you must know the what is cross product, to how to find out the cross product direction. And you had to do your fingers at the in the side of the A, and then cross the fingers at the B vector, and then we will get the C vector direction. Similarly, for this location, and take your right hand side and point your fingers to the X, and curl your fingers to the Y. If you curl your fingers to the Y, then you are getting thumb direction. The thumb will represent the direction of the Z cap, and it is showing it is the wrong direction. The correct direction for this is the below one. Then it is correct. If you want to write the X position here, then the Z direction should be lie below. Then it the right convention. And similarly, you can check it for this the other R's. Y cap is equal to Z cap cross X cap, and this should three rules that should be followed. And similarly, and X cap is the Y cap cross Z cap. You can check it out. The this coordinate system, this direction for this coordinate system is correct. Okay, for the simplicity, and I will take this direction only. This direction only. This is the X, and then this is the Y, and this is the Z. Okay, you can check it out. X cross Y should be in the Z direction. Then this convention is right. Otherwise, it is wrong. Okay, and the other is Cartesian coordinate. Let's suppose I put take any point in free space, and let's suppose this is the r distance from it, r vector, and the position for this x, y, z, and then r vector is nothing but r vector is x into x cap plus y into y cap and z into z cap. Okay, and let's suppose I want to find out the unit vector first. What is unit vector? Unit vector is the unit vector is represented by the cap over it, and r vector divided by its magnitude, and this give you the unit vector, and it is nothing but x cap plus y cap and z cap, and is divided by its magnitude. Its magnitude is the, you have to under root and square the coefficient of the individually the component of the a particular direction, x square, y square and z square. Okay, this will give the unit vector. Okay, then other is unit vector. Let's suppose you have to find out the velocity vector, then you have to differentiate with respect to the time. Then you are getting, I am simply taking the vector, then obviously you are getting x cap plus y dot. I think you know the meaning of the dot. I will illustrate it. Wait a minute. Dot meaning the simply dot. Let's suppose x dot. X dot, the meaning is you are differentiating with respect to the x with respect to the time. And similarly, the y dot means you are differentiating the y with respect to similarly the with the z, and this is the z. Okay, I will represent it with the bigger dots if you feel comfortable. Okay, okay, and this is the velocity vector, you must know. Okay, these are the things that you must know, and others are, if I want to make it general, let's suppose I want to make it general, then what should I do? We partial differentiation, you must know. Let's suppose r vector, let me write it r vector once again. Okay, this is the r vector, and let's suppose you are differentiating uh, complete differentiation. The thing is, you have to first partially derivative with respect to the x, and then complete derivative the x, and then x cap plus and okay, let me take directly first a derivative vector. Okay, and I would not write the unit vectors first. Okay, and r. Okay, then partially derivative with respect to the y and complete derivative the y plus r vector, and then with respect to the z and dz. Okay, and then let's suppose okay, let's suppose this up to here the terminology is same. Okay, then we have to take for the genericity, we had to take we had to assume something. Let's suppose I assume the things let me take the generalized uh, components and the unit vectors. Let's suppose I take generalize. Okay, generalization for the generalization, because we are going to discuss the about the polar and the other coordinates also. Let me take it u1, u2 and u3 and unit vector. Wait for a minute, you will get the things. E1, E2, these are the unit vector in the particular direction of particular direction. Let's suppose it may have the x, y and z cap. Okay, and these are the magnitude in the particular direction of the x cap, y and z. Okay, and then you have to this fraction with the complete derivative the x, and this is we have to assume. Okay, and this is equal to h1 e1, and this is u1 and u2, and it is equal to h2 e2, and then this the rest is u3 and h3 and e3. Okay, and then okay, okay, let me take the next. Okay, and then you have the h1. H1 is nothing but the magnitude of this vector. and h2 is the magnitude of the r vector and u2 vector, and h3 is nothing but the magnitude of the u3. Okay, and then you have these unit vectors are defined as this ratio, and this is the ratio you should know. This is the h1 value, and e1 and e2. Let me write the e2, and okay, and then you have to divide with the magnitude, its magnitude. These are the values, and u3 and divided by its magnitude. Okay, e1, e2, e3 are the unit vector in the particular direction, and if you find out the values for it for the Cartesian coordinates, it come out to be in we can try. Let's suppose you have the r vector. What the r vector we have written? X into x cap plus y into y cap plus z into z cap. And let's suppose what is h1? H1 is here the differentiating r vector with respect to the x. Then if you get the vector, and h1 is the magnitude, sorry, h1 is the magnitude of it, magnitude. Okay, first find out the vector we are getting. If we divide, we are getting only the differentiating with the x, you are getting x cap only, the unit vector. And if you want to find out its magnitude is come out to be 1. And similarly h2, you can go for the h2, and then it come out to be differentiating with respect to the u2, means y, and then it's finding out the magnitude. And the r vector, if you differentiate, you are getting y vector, unit vector, and if you find out the magnitude, you are getting h2 value is 1 only, and h3 value you are getting dividing with the z, and then you are getting unit vector z and 1. I hope so you are getting the things. Why I am directing the magnitude of the unit vector, because it is already unit, and then probably you will get the 1 only. And then other is okay. Now we are going to generalize it, the derivative. We are getting h1 u du1 e1 and h2 du2 e2 and h3 you will get the importance after discussing all the coordinate system. You will get the idea what I am talking about, why I am writing it is in the general form. This is a general form of the complete derivative. You will get to know in the some of the after some minutes. Okay, and then the complete derivative, and just put the values of the h1, h2, h3 in the Cartesian coordinate. We have find the h1, h2, h3 value is 1 1 1 only, and du1 is nothing but x cap, x only. Then it is dx, okay, dx x cap plus d, then it is h2 value is 1, and dy y cap. This is the unit vector, corresponding unit vectors, e1, e2 and e3. You have the corresponding unit vectors are in the Cartesian coordinate. Unit vectors are these only. these are the unit vector you should get. Okay, and h1 h2 h3, if I write the h1 h2 h3, we are getting 1 1 1 1 only. H1 h2 and h3 we are getting 1 1 1 1 1 1, and plus h3 value is 1 dz z cap, and this is the dr vector. Similarly, if you want to find out the velocity component, we can go for the velocity component. Let's suppose you want to find out the velocity component, then you have to differentiate with respect to the t. Then you are getting simply the x dot x vector and y dot, I will write the dot bigger, y dot and z dot z vector. Simply the respective component will have the differentiation with respect to the t, no other issue, with the Cartesian coordinate. So it looks simple, the Cartesian coordinate will look simple. And yes, let me summarize the Cartesian coordinate system. We have a general form of R, and it is x x cap plus y y cap and z z cap simply. And we can write dr vector as simply dx x cap plus dy y cap and dz z cap, differential respective component of the dr. And then let's suppose I want to write the area element, then I have to write, there are basically 3 area element in the x cap direction, and the area element in the zx, and then it is okay, I have written the same thing, x, and then it is in the y cap direction, and dA vector, it is the d x and dy in the z direction. I hope so you can understand it, because area element is always, the direction of the area element is always perpendicular to the plane. Okay, let's suppose I am talking about x, y and z. I am talking about this plane, xy plane. Then the area element have the direction in the upward perpendicular to this plane, and in the downward direction it has the 2 direction. Basically area element have the directions according to that. Okay, and then we have one volume element, and it is simply the dx, dy and dz. So simple. And this is the t. I want to find out the gradient of this t scalar. T is any scalar quantity, and similarly it simply give you the curly x by curly t by curly x, x cap, plus curly t by curly y, y cap, and similarly and curly t by curly z, z cap. T is the scalar function, any scalar function. We take the gradient of a scalar function only, and del operator is represented by curly x by curly x cap plus curly y by curly y cap and curly z by z cap. Simple. And the other is, let me find out the let's suppose v is any vector quantity, and let me find out the gradient of it, divergence of it. Then it is simply come out to be, because remember it, divergence is a scalar quantity, then it simply come out to be their respective component is differentiated with respect to their component, and it come out to be this. Okay, and z cap with respect to the z, I am assuming that b is a vector quantity, but here the t is a scalar function, and a scalar function of variable x, y, z, then I have represented it. And similarly, v is any vector quantity, it has the component in the x direction, it has the vx component, and similarly in the y direction vy, and in the z direction it is having the vz component. And similarly, let me take the then curl of any vector quantity v, let's suppose, then it is simply represented by x, y, and z cap, and then it is the component x curly x by curly y curly z, and then their vx and vy and vz and their respective component. Let me recall all the things once again. We have the h1, h2, and h3 for the Cartesian coordinate. We represent it by the hx, hy, and hz. It come out to be, we have solved it already, 1 1 1. And for du1 and du2 and du3 is come out to be dx, dy, and dz. These are the some general form, we can use this form further. Okay.